Okay, for acceleration, we have two types of acceleration, which is we have average acceleration and instantaneous acceleration. Okay, acceleration is a vector. It doesn't have scalar like velocity. Velocity has scalar, which is our speed, but in acceleration, we have only a vector. So let's say you are at a city A and driving to city B. You are driving with acceleration of 200 km per hour in, let's say, 15 minutes. Okay, at city B for this time. Okay, at city B, you are achieving a velocity of 50 km per hour. Okay. After that, you are increasing your acceleration for a little bit. You're increasing to, let's say you are increasing for just a little bit, 30 km per hour square. Sorry, this is square. Which is you are taking time for 20 minutes. You are arriving at point C, which is you're reaching your velocity as, let's say you are increasing your acceleration, you will get 60 km per hour. Okay, dan lepas tu awak pun tekan brake, you are holding your brakes and you are decreasing by, let's say, negative 150 km per hour square. You are taking the time 10 minutes to reaching point D, which is your point D. At point D, you will arrive with 30 km per hour. Okay, you are approaching A, B, C and D. Then, you will have your displacement vector and velocity vector from point A to B is to the right, something like this lah. So saya letak VAB. And from B to the C also to the right. I will be putting VBC, and also C to D you will get as VBC. You will get something like to the right too. Okay. Okay, now what you have here, kita ada dua definition of acceleration. Yang pertama adalah average acceleration. Okay, average acceleration. By definition, average acceleration kita guna triangle bracket, which is it is rate of change of velocity. Okay, so your velocity is V. Your change, like I said in the previous video, it is symbol by delta. Its meaning as final minus initial. So you will have delta V, which is delta V equal to V final minus V initial. And the rate part is you need to divide what coming after by delta T. Okay, maksudnya awak kena bahagikan change in velocity bahagi dengan change in time. Or you will have V final minus V initial divide by T final minus T initial. Alright, dekat sini kalau tengok contoh yang dekat atas tu, awak akan dapat V final awak adalah 30 km per hour minus V initial awak adalah 0 km per hour. You will get something like divide by, okay, you punya time is in minute. 15 minit tambah 20 minit tambah dengan 10 minit. This is your time. So we want it in hours. We darabkan dengan 60 minit kat bawah dan 1 hours kat atas. So you will get something like 15 tambah 20 tambah 10 bagi dengan 60. You will get something like 0.75 hours. So, kita bahagikan dekat sini. Okay. Awak akan dapat awak punya average acceleration as 40 km per hours square. Okay. However, we can have our acceleration in kilometer per hours, but its SI unit should be in meter per second square. Okay, as I said, average acceleration is average acceleration is a vector, so it should be have direction. But I will show the direction after this. Let's look at instantaneous acceleration first. Okay, instantaneous acceleration. By definition, instantaneous acceleration is, we can say it as A equal to limit t approaching to 0 delta v over delta t, or you can say that your A is differentiate of v over dt. Okay, this is if you have an equation for v, you can differentiate it to get equation of E. Okay, but for your knowledge, or we can have our instantaneous acceleration is acceleration at that point or acceleration at that time. Okay, for acceleration at that time, for example, if I said I want instantaneous acceleration at t equal to 20 minutes after the starting point. Okay, bila kita refer pada soalan pada gambar rajah ni, 20 minit daripada starting point kat sini adalah 15 minit. So, tambah lagi 5 minit. So, saya nak point bila dia berada di sini. Okay, kat sini. So, here, just taking the acceleration here, you will get your A at 20 minutes is equal to 30 km per hour square. And then I can say, I want instantaneous acceleration at what, let's say 35 km from starting point. Okay, if you calculate this, the distance of A to B using your D equal to VT, you will get here your distance is 12.5 km. The distance is here from B to C is 20 km, and you will get the distance from C to D is 5 km. 12 times 20, you will get 22.5, and up until here is 22.5 at 32.5, and I want it at 35. It is in between C and D. So 35 is in between C and D here. So I want the acceleration at this point. A at 35 km is equal to negative 180 km per hour square. So that is instantaneous acceleration. Now, we will look at the direction of the acceleration. Direction of acceleration. So, direction of acceleration, will depend on the direction of velocity. Depend but not following. Remember that the direction of velocity will be following direction of displacement. But for acceleration, it's depend, not follow. Depend on direction of velocity. The rules is, okay, we have rules. If you are accelerate, which is your acceleration is increasing, you will have direction of A same as direction of V. But if you are decelerate, your acceleration is decreasing. Okay, direction of A is opposite direction of B. Okay, let's say you are moving to the right. This is your car. You are moving to the right. Okay. You are moving from 10 km per hour to 15 km per hour. When you are moving to the right, your displacement is to the right and your velocity will be have the direction same as the displacement, which is also to the right. This is your V. And you can see that the velocity is increasing, showing that your acceleration is also increasing. Okay, maksudnya dia accelerate lah. Kalau dia accelerate, dia mesti sama direction as V. Okay, this is for accelerate. But in another case, when you are moving from, let's say, 60 km per hour to 20 km per hour, you are moving to the right. Okay, you are moving to the right. Your velocity should be to the right, but you are decreasing. Your velocity is decreasing. Okay, which mean you will get your A opposite with the V. Okay, in another case, you are moving to the left. Okay, you are moving to the left. Your V is to the left. But you will have, let's say, you are starting with 10 km per hour, increasing to 15 km per hour. Okay, 50 km per hour. What happened here? You are accelerate. That means your A should have a direction following the V, same as the V. If you are decelerate, okay, let's say you are here with 20 km per hour. You are moving to the left up until you are 60 km per hour. Your V is to the left right now, and your A should be opposite with V because you are decelerate. Okay. Another rules that you can attain from here is if your A and V is same sign, you are accelerate. Okay. If your V and A opposite sign, you are decelerate. Look at the first situation where your V is to the right, so your V is positive. This is A, sorry. Okay, so your A is also positive. You can say both are the same sign, both are positive. Okay, situasi yang bawah pula, your V is to the left, your A is also to the left. So both have the same sign. So it shows that it is accelerate. And this situation, your V is to the right, your A is to the left. So one have positive, the others have negative. Same for the below situation, your V is negative, your A is positive. Both have opposite direction. So it is decelerate. If it has same sign, it is accelerate. If it has opposite sign, it is decelerate. Right? Okay, for this one, from A to B, you are accelerating. So the direction of A is to the right, and for B to C, it is also accelerating. Your direction of A to the right, but from C to D, you are decelerating, so your A is to the left. It is opposite with the V. Okay.